This is multiplying and dividing rational expressions, part 2. All right, you can multiply rational expressions the same way that you multiply fractions. So here's some rules about multiplying rational expressions. We want to factor all numerators and denominators completely. That'll make life really easy. Divide out common factors of the numerators and denominators. Multiply numerators, then multiply denominators, and be sure the numerator and denominator have no common factors other than 1. So you might want to copy this down or make a copy. There's some notes in your resources section on RenWeb. You can pull those up and get a copy of it from there too. Okay, so let's practice multiplying rational expressions. The first thing we could do on our first one is just multiply across. 10 times 3 is 30. And when we multiply variables with exponents, we just have to add our exponents. So 5 plus 3 is 8. Now for our y's, again, we're just going to add our exponents. So 3 plus 4 is 7. On our denominator, 2 times 9 is 18. X to the third and x squared is actually x to the fifth. And y to the second and y to the seventh and y to the fifth is y to the 12th. All right, now we can reduce this. I know that 6 goes into 35 times. 6 goes into 18 3 times. So let's go ahead and write that out, 5 over 3. Now, when we're dealing with division, we subtract our exponents. So 8 minus 5 is 3. That's positive, so it's going to go up here. 7 minus 12 is a negative 5. So that's going to leave our y in the denominator. So here is our final answer for A. B is a little bit different. We're going to go ahead and multiply everything out. So x minus 3 times x plus 5. And let's look at the bottom in our denominator. 4x plus 20. I see that I can factor that. So I'm going to go ahead and factor that by taking a 4 out, and that leaves me with x plus 5. So I'm going to go ahead and put a 4 times x plus 5, and then notice I have an x squared minus 9. Now that is the difference of two perfect squares, so that's going to be x plus 3 and x minus 3. So I'm going to go ahead and put those up here, x plus 3 and x minus 3. Now let's see if there's anything I can cancel out. And I see that I have an x plus 5 and an x plus 5. I have an x minus 3 and an x minus 3. And so what I have left is just 1 over 4 times x plus 3. And so there we have it simplified. All right. And here we'll just check them. And there it is. All right, so try these two on your own. Turn off your video and then give them a try. Okay, once again, let's just multiply everything across. This is going to leave us with 20x to the 8th. And multiplying across 15 times 2 is 30, x to the 5th. I see that 10 goes into both of these. That's going to be 2. 10 goes into 33 times. We subtract 8 minus 5 is 3, so that's going to be x to the 3rd. And then on our other side, we need to factor b. Let's factor that. We can factor a 10 out. That leaves me with x minus 4 times x plus 3, right there. And on the bottom, I'm going to have to factor two numbers that multiply together to get 8, add together to get negative 6. That is going to be negative 4 times negative 2, gives me a positive 8 and a negative 6. So let's go ahead, x minus 4 times x minus 2 times, and here I can factor out a 5, and that leaves me with x plus 3. So let's write it all together. I have 10 x minus 4 x plus 3, and that was from up here, divided by, and let's go ahead and put my 5 in first, x minus 4 x minus 2 x plus 3. That's all of this right here. All right, and now I can actually divide. and I can cancel out my x minus 4s. I can cancel out my x minus 3s, and notice I see that a 5 goes into that one time, 5 goes into 10 two times. So my final answer is going to be 2, and there's nothing else on the top, and in the denominator I have x minus 2. So there is my final answer. And let's just check this. 2 over 3 x to the third is correct. And we can't see it, but 2 over x minus 2, that's correct also. You can also divide by rational expressions. Recall that to divide by a fraction, you multiply by its reciprocal. So when I was teaching this a long time ago, I just helped my students remember to keep, change, flip. All right, so we're going to keep the first one. We're going to change the sign from division to multiplication, and then flip, or do the reciprocal, 4 over 3. Keep, change, flip. And now we could just multiply over. We get 4 over 6, and I see that 2 goes into both of those. 2 goes into 4 2 times, 2 goes into 6 3 times, and that's all we have to do a simple division problem. Okay, so here's a division problem. It looks a little more complicated, but it's pretty much the same. Remember, we're going to keep, change, flip. So the first thing we want to do is rewrite as multiplication by the reciprocal. There it is. And then I like to go ahead and just cancel out as much as I can to get started with. So I see there's a 5 here and 1 5 with a 3 left over. And I see 8 goes into 8 both times up there. So I end up with x to the 4th, y to the 5th on the top, and on the bottom I just have a 3 x squared y squared. And now all I have to do is go ahead and I can deal with my x's. Remember, if there's a division, I subtract my exponent. So 4 take away 2 is 2, so I have x squared on the top, and 5 take away 2 is 3, so I have a y to the third on the top, and then I still have that 3 on the bottom in my denominator, and so that's all we have to do. And our answer is x squared y third over 3. Okay, so let's try this example. Again, it's division, so we want to make sure that we remember our rules for division. We're going to keep, change, flip. So once we rewrite it like that, now all we have to do, let's go ahead and get these factored out a little bit here. So here I see that I can factor out an x squared out of both of this. So that would leave me with x squared. And then that would leave me with x squared minus 9, which is the difference of two perfect squares. So let's say that's x plus 3 and an x minus 3. Over here, I see that's the difference of perfect squares. That's going to be x plus 4 and x minus 4. All right, so now let's deal with our denominator. Here we need to factor this out, so we're going to say two numbers that multiply together to get positive 3, add together to get negative 4. So let's say negative 3 times negative 1 would do that job for us. Negative 3 times negative 1 multiplies together and adds together to get 4. So let's go ahead and write that down, x minus 3 and x minus 1. And then over here, again, I could factor out an x squared first. So I'm going to say x squared, and that would equal this. Now we're going to find two numbers that multiply together to get x, or 8, add together to get 2. And that would be a 4 and a, that's going to be negative, and a negative 2. And so we have x plus 4 and x minus 2. So I'm going to go ahead and put my x squared over here, and I'm going to put my x plus 4 and my x minus 2 here. So now comes the fun part. We have this really long equation, but we can start canceling things out. Our x squares cancel out. It looks like I have an x minus 3 and an x minus 3, and I also have an x plus 4 and an x plus 4. So in the end, what I have is x plus 3 times x minus 4, and all of that is divided by x minus 1 times x minus 2. There you go. All right. So the next thing I want you to do is try this one on your own. Same kind of thing. So turn your video off and give it a try. Okay, so first of all, let's remember to keep, change, flip, do the reciprocal, multiply by the reciprocal. And next what you would need to do is we just have multiply that together. We get 12x squared y squared over 4x to the 4th y. We can cancel 4, and 4 goes into that 3 times, so we're going to end up with 3. And then our x's, we subtract here, so 2 take away 4 is negative 2, so that's going to leave me with y and x in the bottom. And 2 take away, this is an understood 1, so that would leave us with 1y up here. So our answer is going to be 3y over x squared. I hope you were able to find that by yourself. Okay, here's another one for you to try on your own. I really want you to try this one on your own because I want you to see if you can factor this out. This is going to be good practice for you to working on your factoring. So turn your video off and try. All right, on this one, again, it's a division first, so we're going to keep, change, and flip. And so when we do that, here's our equation or our expression that we're going to work with. So the first thing I want to do is go ahead and factor our first piece. So here I have a 2 and in front of my x squared, so I'm going to have to expand this one. So I'm going to write 2x squared and my negative 4 here. I need to find two numbers that multiply together to get negative 8, and I got negative 8 by 2 and negative 4, and add together to get negative 7. All right, well, I know that is negative 8 times a positive 1, so I'm going to write negative 8x plus 1x, and that equals my 7x, and then my minus 4. So I'm going to go ahead and write that down here so we can see it a little bit better. 2x squared minus 8x plus 1x minus 4. All right, so I'm going to group these together and see if I can factor again, and I can. I can see that there's a 2x I could factor out, so that leaves me with x minus 4. And then here, I already have an x minus 4, so the only thing I really want to just factor out is I'm just going to factor out a 1, or just remember that there is a 1 there, so that's going to be 1x minus 4, or just x minus 4. Okay, so now I can see that I can factor out an x minus 4, so it's going to be x minus 4 times 2x plus 1. So that's a tricky part with that particular expression here. So we're going to go ahead and write that in as x minus 4 times 2x plus 1. All right, next I'm going to go ahead, actually I need to put this up here, x minus 4 times 2x plus 1. All right, next let's go ahead and deal with this. It's x squared minus 9. We can see that that's the difference of two perfect squares, x plus 3 and x minus 3. All right, we're going to keep on going. Here I have 4x squared minus 1. It's not easy to see at first, but it's actually the difference of two perfect squares. So that's going to be 2x plus 1 and 2x minus 1. So I'll go ahead and put that over here. 2x plus 1 and 2x minus 1. Now we just have one more hard part, and that is this last expression. And it's a little bit harder to factor because we have 2 here. So I'm going to go ahead and write this out, and let's see if we can get it factored. So we have 8x squared minus 28x plus 12. So remember, we're going to expand, and we're going to have 8x squared and our 12 plus 12 here. Now we have to figure out two numbers that multiply together to get positive 12 and add together to get negative 28. So what I'm going to do is I'm going to go ahead and put my 8 times 12 together, and I'm going to find all the factors of my 8 times 12. And 8, I know the factors of 8 are going to be 2 times 2 times 2. And I know my factors of 12 are 2 times 2 times 3. So now I need to figure out how can I arrange this so that I have two numbers that multiply together to get 8 times 12, which is actually 96, and add together to get my negative 28. Well, you can go and look through all of these several times, and also you can put in your calculator. But I'm going to look here and see if this is 4 times 3 times 24. If I have a negative 4 times a negative 24, that multiplies together to get 96, and it also adds together to get negative 28. So now that I know that, I'm going to go ahead and change my negative 28 to say negative 24x plus negative 4x. Okay, so now I can factor these a little bit better. I'm going to clean this up just a second here. So I'm going to say that's 8x squared minus 24x plus a negative 4x plus 12. All right, and I can group all that together. And I see that I can factor out an 8x here. That's going to leave me with 8x minus 3. And here I can factor out a negative 4. That leaves me with x minus 3. So that is going to leave me with 8x minus 4 times x minus 3. Now notice that my 8x minus 4 can actually be factored out a little more. I can actually factor out a 4, and that leaves me with 2x minus 1. So I'm going to erase the 8x minus 4 and leave this new one in here. Okay, so now comes the fun part where we get to cancel things out. So x minus 4, I don't see any other x minus 4. 2x plus 1, 2x plus 1, those cancel out. 2x minus 1, 2x minus 1, x minus 3, and x minus 3. So my final answer, I see I'm going to have a 4 and an x minus 4. So 4, x minus 4 over x plus 3. So that whole thing divided out ends up being 4 times x minus 4 divided by x plus 3. Okay, so now we're going to take everything that you've learned and set it up as a simple equation, and we're going to solve it as an equation. So all we have to do, it's not that difficult, is we're just going to take our first part, which is x squared minus 25, and we can factor that. We see that that's the difference of two perfect squares. But before we get started, let's just remember this, x minus 5. Now remember, if that equals 0, then our equation is undefined. Okay, so we can't let x equal 5. So the first thing we need to note is that x cannot be 5. So as long as x is not 5, we're good. So let's go ahead and factor out our x squared minus 25. So x squared minus 25, we know it's going to be x plus 5 and x minus 5, because that's the difference of two perfect squares. And on the bottom, we have an x minus 5 in the denominator, and now lucky us, we can actually cancel these out. So we end up saying x plus 5 is just equal to 14, and so now we can just solve by subtracting 5 on both sides. So we end up with x equals 9, and notice x does not equal 5, so it is a good answer. So x equals 9, and you can check. Always you could check your answers. So substituting for x is 9, we just substitute in, multiply it out, and sure enough, 14 does equal 14. Okay, so here's another example that we're going to try. The first thing we want to do is take a note of what our solution cannot be. It will be undefined when x equals positive 2, because 2 minus 2 is 0. We can't have a 0 in our denominator, so let's keep that in mind. All right, so let's go ahead and factor this out. So in order to factor that, we need to find two numbers that multiply together to get negative 10, add together to get 3. Well, I know that's 5 times negative 2. 5 times negative 2 is negative 10. 5 plus a negative 2 is 3. So I'm going to factor that, x plus 5 and x minus 2, and all over my denominator, which is x minus 2, and that's going to all equal 7. So I can cancel out my x minus 2. Those cancel out. So that leaves me with x plus 5 equals 7. Let's go ahead and solve for x minus 5 minus 5. So I end up with x equals 2. Well, that's a problem because I said that x can't equal 2, otherwise it will be undefined. So what that tells me is that because the left side of the original equation is undefined when x equals 2, there is no solution. All right, so you would just say no solution for this problem. All right, and again, we can use your calculator to check and just put that equation in your calculator as y1, and for y2, put in 7, and when you do that, you will see that when x is 2, it tells us that there's an error, so that means that there's no solution when x is 2. All right, try this one on your own. Turn your video off and give it a try. All right, so once again, I hope you could see that all you needed to do is factor this first. So we're going to find two numbers that multiply together to get negative 12, add together to get 1. And I know that that is going to be 4 times negative 3. So I'm going to say x plus 4 times x minus 3, and all of that divided by x plus 4. So my 4's x plus 4 cancel out. It leaves me with x minus 3 equals negative 7. Add positive 3 to both sides. So I have x equals negative 4. Now let's come over here and take a look at this. My denominator is x plus 4. And so if that were to equal to 0, x could not be negative 4. Otherwise, I have no solution, and it turns out that x is equal to negative 4, so in the end, the answer is no solution. All right, since x is negative 4, because the left side of the original equation is undefined, x equals negative 4, there is no solution. And again, we can also use your calculator to check. So put in your y1, your original equation, and y2 is what it equals to, negative 7. When you go to table, you'll see that at negative 4, it comes out error, so it tells you that you got your problem right. Okay, one last one for you to try on your own. Turn your video off and do this last one on your own. All right, so when we look at this, I see that this is the difference of two perfect squares, 2x plus 3 and 2x minus 3, all divided by 2x plus 3. All right, so let's just remember what it cannot be, and if this is going to be undefined. So 2x plus 3, if that equals 0, it'll be undefined. So 2x equals negative 3. So when x equals negative 3 over 2, it's going to be undefined. All right, so back up to what we've been working on. I see that I can cancel out 2x plus 3 and 2x plus 3, and that equals 5. So we have 2x minus 3 equals 5. So let's add 3 to both sides. We have 2x equals 8, so x equals 4, which is not negative 3 over 2. So our solution is going to be x equals 4. And of course, you should always check your work, substitute 4 into your original equation, multiply it through, and you will see that it does indeed equal 5, and you got the problem correct. Okay. And that is the end of our very long lesson. If you'd like to turn the video on pause and try these extra problems to make sure you are comprehending and getting this correct, that'd be great. Here are the answers for you. X minus 1 and x plus 2, and that is when x cannot be negative 2 or 5, otherwise it would be undefined. And for the second one, negative x over x plus 1, and it would be undefined when x is equal to 1 or 6, so x cannot be 1 or 6. Here are some more samples for you to try on your own if you'd like. And your answers are 2 over x minus 1, and there's the next one, and your final one. Okay, well, that is the end of this lesson, and I hope you learned a lot. I know it was very long, so have a great day, and I'll see you in class. Bye. And that is the end of multiplying and dividing rational expressions, part 2.